here is the solution to number 7 on page 135 from chapter 4 in the physics book on forces. This is a good example of the kind of problem that you're going to see a lot. It's going to start with a free body diagram, and then we're going to work the problem by resolving all the vectors in the x direction and all the vectors in the y direction to figure out the resultant force. Here's the question. A 5 kilogram block at rest on a frictionless surface is acted upon by forces F1 and F2 as illustrated here. What additional force will keep the block at rest? So I've drawn the given information in black ink, and I'm going to work this information in red ink. One thing that I want to pay attention to is that in the y direction we have this force we're not going to worry about that force. We're just going to resolve these forces like this, okay? So in this direction, in this force, which the book calls F sub 2, and this is F sub 1, we have F sub 2 is acting at 37 degrees, so it has two components. It has this one, which I'll call F sub 2 in the y, and this one, which we're going to call F sub 2 in the x. So let's solve F sub 2 in the y first. F sub 2 in the y is equal to, this is the opposite of 37 degrees, so in other words, 3.5 sine of 37 is what we're looking for. So if we take our calculator, we've got 3.7 sine times 3.5 equals it seems a little low. Let me try it again. 37 sine times that's much better. So that is F sub y is equal to 2.11 newtons. Okay? F sub 2 in the x, same logic, it's going to be 3.5 cosine 37. So F sub 2 in the x is equal to 37 cosine times 3.5, 2.795. So what we did is we just broke this vector running along here, into the two parts, x and y. We'll do the same thing for F sub 1 over here. Notice that this vector is directed downward, this vector is directed upward. So our signs on this are both positive, but our sign on this one is the y vector is going to be negative. Okay? In this one, F sub 1 in the y is equal to sine of 30 times 5.5, which is 2.75. Notice that that one's directed downward, so I'm going to put a negative on it. In the x, it is cosine, 4.76. Alright, so all you have to do now to figure out this problem is to sum all the forces in the x. And so the sum of the forces in the x is equal to this vector, 0.76, plus this vector. And so you get a vector that's 7.555 newtons directed to the right, and this one, so that's positive, and this one is F sub forces in the y, In the y, remember we have one negative, negative 2.75 newtons, and 2.11 newtons, so that is negative 0.64. So the question is, what force is going to have to act on this box so that the box doesn't move? These are the sum of the forces that are acting on the box now. So the force that's exactly going to keep the box from not moving is one that balances all these forces. So that means I need a force that's acting in this direction at 7.555 newtons, and this that's 0.64 up. All right? And so that's that vector that you would be talking about. The book just simply gives the answer like this. The book says the answer is a vector that's 7.555 newtons in the x and 0.64 newtons in the y. I would prefer that you did the Pythagorean theorem to really figure it out. 7.555 squared plus 0.64 squared equals square root. So really it's a vector that's 7.58 newtons at, and so this angle would be the tangent of 0.64. .8 degrees at 4.84 degrees above the horizontal. Okay?